Okay, we're good. All right, are you guys open on the quiz then?
Yep.
Yeah.
I'm going to skip that first part. Okay, so for each of the next 4 questions, identify the one hypothesis test that is most appropriate to the given situation. In an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared education level, high school, undergraduate degree, master's degree, doctoral degree, of people who manage successful startup companies in the United States and Korea. You want to determine if education level of managers of successful startup companies is independent of the country they are from, the United States or Korea. Which hypothesis test would be most appropriate for this analysis? And I said the chi-squared test of independence.
Yeah, I got it wrong once already, so I feel like you're right. I tried it. But that was going to be my second choice.
I need to write down all of these tests and a description next to them because it's so hard for me to decide.
Well, I feel like I was so good up until this week, and then this week all of a sudden I can't remember what any of them are.
That's exactly how I feel. And there's so many
So what did you put that was wrong then, Russell? Just curious.
Test of 2 proportions.
Oh.
That's for sure wrong.
Just as kind of a guess, I'm just shooting one out there. I had written down independent sample t-test.
So the only reason I did this is because it sounds like categorical data. So you use categorical data for the proportion, chi-squared. So it's not quantitative because you don't have numbers assigned to everything.
I got it.
So I said categorical, which would make it a proportion, or the chi-squared. And then because it is doing, where is it? It says you want to determine if education level of managers of successful startup companies is independent of the country they are from. So because it was doing independence, to see if one was independent of the other is why I did the chi-squared test.
Okay, I'm
following. I was kind of thinking the same thing, so hopefully it's right.
Good thinking, Sarah.
Thanks.
All right, you want me to go next?
Sure. Hi, Mary.
Hi. I thought, am I confused? Were we not meeting Thursday? I thought we were not meeting today.
We're not
on
meeting
Thursday.
Not on Thursday. Okay, sorry, my bad. I was sitting here doing my work, minding my own business.
It's okay. Just blame it on Russell.
Whoa!
He sent out the email.
And Russell's fault.
I was thinking about my sparklers next Tuesday, and that's what's throwing me off.
Let me get logged in. You guys carry on. I'll get logged in.
Okay.
All right.
Just taking question 3 here. So.
Question 3. All right. A human resources manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis? And this one is test of 2 proportions.
Yep, that's what I put.
That one I know is right.
What?
I had that
What number is this?
Number 3. We're really far along.
Yeah. Cruising.
Okay.
The survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis? I really don't even know. Independent sample t-test?
Test of 1 proportion.
That's what I put.
Okay.
That one's right. I know.
And I did that because it has, well, one, it has a percentage sign in there, so that
Okay.
a good hint that it's a proportion. And it's comparing, and it says proportion in there, and it's comparing one proportion to the population proportion, so it's not two.
Okay.
The next one I don't know, so don't ask me on the next one.
Mary Ann can take that one. Your turn.
I'm all over it. By the way, I really suck at these, so.
It's okay. We're batting like 1,000 right now, so don't even worry about it.
All right. A student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They want to determine if one of the locks is easier to open. Which hypothesis test would be most appropriate for this analysis? Okay.
I'll be honest, I'm not on this one.
I wrote down, what did I write down? I wrote down a 1 sample t-test, but there is a question mark at the end of that, so.
I can tell you it's not independent sample t-test.
Okay, so that one, I think it's the paired samples.
That's what I think too, because you've got 2 different locks.
But it's the same student.
But it's the same person. So one lock depends on, your data from one is dependent on the data from the other.
Yeah, because if you have the same student, if your student really sucks at opening locks, they're going to suck at opening.
You're just going to suck no matter what.
Okay, so if you are comparing the student who's opening one lock and then you're comparing his time with the second lock, then yeah, I guess it would be paired samples because you're comparing, right?
Yeah. That's my guess. I honestly am not 100% sure though.
That's my guess too, Sarah. So we have 2 guesses the same.
Okay.
And I'm going with it because
So is that right or no? It is
the same person twice, then you expect the measurements to be dependent on each other.
I love when he just comes in and does so much work.
like Superman, just shows up.
okay.
I feel like if I was him one day, I'd just come and be like, you guys are so dumb.
Okay.
That's not how you do any of this.
Everything's compared.
Oh, so are we good? Is it my turn then?
Sure.
All right. For the next 3 questions, identify the one confidence interval that is most appropriate for the given situation. So we're on question 6. A bank employs 2 appraisers when approving borrowers for mortgages. It is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for this study? And I said the paired samples again.
Bank employs 2.
Also not 100% sure on this one, especially since we lost on those paired samples. It makes me a little worried.
Well, I can tell you once again that this one is not independent samples T confidence interval.
Okay.
If that helps. Now we're down to 5.
Well, what is independent samples then? If you know so much about what it isn't, what is it?
I don't know. That was my best guess at the time after reading through everything.
Oh, you know it's not it because you got it wrong.
Right.
Here.
That's what I was trying to say without saying that on the recording. Thanks for calling me out.
Sorry.
Okay. Does anybody object to my bringing my husband over here?
No.
Clark Kent, bring him in. Ones that you
Well, I
don't-
think
Will you read this and explain which one it is and why it is that one?
well, one's independent of the other, obviously. So if you go and survey kids in Africa and you survey kids in America, obviously they're going to be independent samples, you know. So I think when you compare the kids in Africa to the kids in America is when you use the independent sample. But where you're using 6 properties that both of them did is when I would say the paired samples, because they both did it.
Yeah, you'd expect there to be some connection between the two measurements. Yeah, fair.
Okay.
Whatever, Sarah. Whatever.
Sorry, I'm not trying to
Show off.
She's taken this class twice now.
Yeah, that, and I'm just guessing 90% of the time.
Just send us the answers if you already have them.
I have them, but I don't know if they're right.
Okay, I'm next.
Yep.
In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study? And it is confidence interval for 2 proportions.
Yeah, that's what I had.
That is what I put.
You guys are correct.
All right, double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study? Is it paired samples, independent samples?
It is not independent.
You thought everything should be independent.
I don't. Every time I've guessed that, it's been wrong. So no.
Okay, not independent.
Well, I put one sample t-test, but now I feel like it's something different. Like, I have to reread it. Hold on.
Well, it says in order to compare it to the filling amount in regular Oreos.
Yeah.
Paired sample? I don't know. 2 proportions?
I don't know.
It wouldn't be proportion because you're
Because we don't have.
in
Yeah.
this case you'd actually be comparing a weight.
The only thing I would say the one sample is because you take a single sample of 55 double stuffed Oreo cookies, and I think you're comparing it to the mean of the regular Oreos. So you're seeing how it compares, but you're not taking a sample of the regular Oreos.
All right, so 1 sample T.
That's what I put.
That's
but
what I put.
Okay.
That's the only reason I put it is because they didn't say that they took a sample of regular Oreos.
You know what? I agree.
Sounds good.
By the way, am I the only one that's noticed that the last 3 questions, Russell has said it's not independent samples?
Hey! I already called myself out. You don't need to stick me again.
You didn't call yourself out. Amanda called you out.
No, it's just funny.
If you don't know, just go with that one and you'll be wrong.
Perfect. Sounds great to me.
I feel like
All right.
independent samples is your letter C for this.
Okay, listen. I only missed 5, so there's 3 of them, okay?
All right, good.
Let's see. Which one of the following best defines the notion of the significance level of a hypothesis test? And I put the first one. Probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
I had something different.
I got something different too.
Did I? Oh, I think I mixed these up. Oh, I mixed these up. Sorry.
Okay.
It would be the third one then, the probability of rejecting the null hypothesis, whether it's true or not.
I still have a different one.
I have the probability of the type 1 error.
Yeah, that's what I have.
That's what I have.
Ah,
It's okay.
If the camera wouldn't make me like crash, I would give you a wink wink on probability of type 1 error.
oh wait, see, and I'm still marking the wrong thing. Here we go. Let me get the mark the right thing. Here we go. Okay.
Okay. Which one of the following best defines the notion of the p-value of a hypothesis test? And I said the third one, the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
Me too.
Yes.
Me 3.
Is that a wink wink?
Yep, I agree. Okay, suppose you create a 95% confidence interval for a mean and get 10 and 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? 95% of all 95% confidence intervals actually contain the true mean.
Yes.
I'm going to go with it because I was not sure on this one, and I got this one wrong on the last test.
I miss these questions every single time. Every quiz I miss these. So
Go with the ones that look like this, that say like 95% of 95%. Every time you'll be right. That's what I do. I've gotten them right every time.
all right, good.
Well, one thing she told me last time when I took the test, she said if it says chance, then it's probably wrong.
Yeah, because it's not a probability.
I like that.
So my husband explained this, and if you take a bunch of confidence intervals and you put a bunch of confidence intervals together, 95% of those confidence intervals will have the sample mean within them.
Okay.
It was a big visual that we did, because I'm visual.
The intervals center around different point estimates. So they'll.
Can you hear him?
The intervals are going to center around different point estimates, which means they're going to vary a little bit from sample to sample. But because of the width that you've chosen, that interval width, 19 out of 20 of them, or 95% of them, are going to be wide enough that no matter where they're centered, some portion of them is going to include the actual true population mean. You don't know what the population mean is, and for any given interval, you don't know if it's going to contain the population mean or not. But it's not a chance that it will contain. The interval either contains it or doesn't contain it. But if you took a bunch of samples centered around a bunch of different values and had intervals of that width, most of them would be wide enough to capture the population, the unknown population. 95% of them would be.
Hey, Marianne, tell him that if he puts another pair of shoes on, it would have been just like Mr. Rogers, because he took his shoes off perfectly, one at a time.
I wasn't watching the video. I missed it.
Oh, you missed it? That's all I could think of, was I was watching him take his shoes off.
I'm seriously going to go get a cardigan, because I have a gray cardigan that would be perfect.
It's a beautiful day in the neighborhood. All right, we better move on.
Colors of every sweater that he wore in the entire show is like a graph.
Well, it'd be lovely.
All right. Use the following information for the next 3 questions. You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in the town who invest in the stock market is P equals 0.3 or 30%. What is the mean distribution of the sample proportions? And I put 0.3.
That's
Agreed.
fine.
Yes. All right. Is it me?
Agreed.
Let's see. What is the standard deviation of the distribution of the sample proportions? And I have 0.458.
I have 0.046.
That's what I have.
Yeah, I have the 0.04.
Oh, we're all different. How fun.
Well, I had 0.0458, but that would round to 0.046.
Yeah, I had 0.046.
Okay. Let me try this again. Make sure.
I put it in the Excel sheet, I think, is where I did it from.
How did you do it in the Excel sheet?
Oh, maybe I didn't. I don't know.
Well, I don't doubt that you did. I just want to know how you did it if you did.
Well, yeah, because it doesn't give you enough information because you need to have X and N, right? So you have
Well, your
N.
N is 100.
You're right.
Your sample's 100.
Mm-hmm.
Your X would be-
And maybe I didn't do it in the spreadsheet. I don't remember now. I did this morning.
I did it
So
by
can you just back it up because P is X over N? So can you just do 0.3 times 100 or 0.3 times 100?
You can do it in the spreadsheet too. You just have to do your X would be 30 because that's what your P value is, and your sample's 100. So you can do it in the spreadsheet. I just tried it.
Okay, so I'm going to do it right now. So for N, you put in 100, right?
Yeah.
What, and X is 30?
Yeah, that's all you need.
What's your null hypothesis here?
It doesn't matter because you don't need it for the standard deviation.
Okay, so in that case, then I have 0.046.
Yeah.
Which is what everybody else has.
Yep. So what is the probability that your random sample of 100 adults will have a sample proportion less than 25? Hold on 5 seconds because I just want to check my answer. I had 0.138, but in the Excel spreadsheet,
I
it looks
agree.
like- do you?
Uh-huh.
Oh, well, that's not in the Excel spreadsheet anyway.
0.138, right? That's what you said?
Yeah.
Yeah, I agree with that.
Okay. I just
That's what I had too.
did you get that in the Excel spreadsheet?
Maybe not.
By
I
hand.
really don't remember now. Now I'm like wondering if I really just did it by hand.
Well, because I did it by hand, but I got something different in the Excel spreadsheet. Because it would be the p-value, right?
Yeah. I did it by
And
hand. And round it up because it was 0.1376 and round up to 0.138.
because in the spreadsheet I have 0.876.
We better go with Russell's answer.
No, it was Sarah,
Well,
it was
I mean-
Sarah- it was Sarah's answer. I'm just agreeing with it.
I just am trying to figure out how I did it wrong in the spreadsheet. I don't
Well,
know.
that's what my spreadsheet looks like too now that I'm doing it right here. So I must have done it by hand because that's not what I wrote down earlier.
That's weird. All right. I'm just going to ignore it, I guess.
All right. Use the following information to answer the next 7 questions. Acupril is meant to control hypertension. In clinical trials of Acupril, 2,142 subjects were divided into 2 groups. The 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril. Create a 95% confidence interval for P1 minus P2. Input the margin of error, lower and upper bounds below rounded to 3 decimal places. What is the margin of error for this 95% confidence interval? And I have 0.016.
That's what I have.
Okay, input the lower bound. And I have a negative 0.003.
Yep.
Agreed.
That's what I have. And then the upper bound, I have 0.029.
Yep.
Agreed.
Perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different than the proportion of control group subjects who do. Use a level of significance of 0.05. What are the appropriate null and alternative hypotheses? I said the first one.
Agreed.
Yep.
Agree.
The value of your test statistic is 1.458.
Yep.
I have a different answer, but that's what my spreadsheet says right now, so I'm going with it.
The p-value of your test is 0.145.
Yep.
Agreed.
Alrighty. Is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupril is different than the true proportion of people who experience dizziness while not taking Acupril? And I put, yes, I failed to reject the null hypothesis.
I put something different.
I said no, I failed to reject the null hypothesis.
I agree with that. No, I failed to reject the null hypothesis. What I got?
I think I meant to put that, but I was talking with my husband. And I was like, yes, okay, yes. No, I failed to reject the null hypothesis. So the last one.
Yeah.
Okay. Gosh.
All right. A survey was conducted of 1,279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? The hypothesis for this study are the null being a morning or evening person is independent of age, and the alternative being a morning or evening person is not independent of age. The results of the survey are given here. Conduct a test of independence. Use a level of significance of 0.05. Calculate the test statistic for the hypothesis test. Assume the requirements for the test are satisfied. And I said 612.297.
I got something different.
I got something different.
I got 6.58.
That's what I have.
That's what I have.
6.58.
6.58.
Awesome. Okay, I gotta go figure out what I did wrong.
Like kind of a lot different.
It's only 606 different.
Well, I really couldn't tell you why it was so different, but I remember thinking, man, that's a big answer.
I had the same thing happen. I was doing the homework last week, and I did it step by step what the book had said, and for some reason I got like 300 something, and the book had like one point something or other, and I thought, how are we so off? I followed the directions, and for the life of me, I could not get the right answer.
So let me let me just check really fast. Make sure I did this right. I don't understand why it's giving me such a big answer. Okay, so you guys made a table, right? And so you did each thing. So like my first row, not my first column, but my first row includes an age, whether they were a morning person or not, and then the count.
Uh-huh.
Uh-huh.
You weight the classes by the count.
Mm-hmm.
Mm-hmm.
Okay, and then I have all of my counts right. Yes, okay. And then you go to descriptive statistics and do the crosstabs. And the ages for one and whether they were a morning or an evening person for the other.
Mm-hmm.
And you click on the chi-squared in the statistics box and the display clustered bar charts, and then you say okay, right?
Uh-huh.
And then you get an answer of 612. Oh, I don't understand it. It's okay.
I would say I remember.
Do
but
you
I don't.
want to see how? I don't know if I can.
It's okay. I think
I can show you how I've set up my table, and maybe that would make a difference.
It's okay. I think.
Can you share your screen and show how you did your table?
It's okay. I think I just put something in funky. I'll have to go look through it. It's not a big deal.
Okay.
You sure?
Yeah.
Okay. Calculate the p-value for this hypothesis test. Assume the requirements for the test are satisfied. And I have 0.087.
Agree.
That's what I have.
All right, I'll go with it because my thing's being funky.
Okay, should you reject the null or not explain? And I said, no, the p-value is greater than 0.05.
I agree.
Agreed. What do you conclude based on your results? We have insufficient evidence to say that being a morning person is not independent of age. Right? If we fail, sorry. Hold on. Sorry, let me go back a second. I got 0.087. Yeah. I always get these wonky. Am I wrong?
I got this one. I got this one wrong, and I don't remember which one I picked, so I can't even help. I have no idea. I'm hoping you guys can explain it to me.
Okay, so the p-value is greater than
the level of significance. So we failed to reject the null.
So you have insufficient evidence
to say that being a morning person is not independent of age, right?
To say that, yes.
So it's the last one.
Yes.
Your
Wait.
null hypothesis is that they are.
Yes, but you're supposed to go back and restate the alternative hypothesis, whether it's sufficient or insufficient evidence, right? That's what.
Insufficient evidence to reject the null hypothesis. That they are.
Hold on just a minute. I gotta go.
So wait, you're saying that
I'm saying I have insufficient evidence to show that being a morning or evening person is not independent of age.
it's not.
Not independent of age.
If you have insufficient evidence that it's not independent, that they're related. That suggests that they're related. Insufficient evidence is not independent.
So if I fail the null, what am I doing? Did I fail or did I?
Failed to reject.
So I failed to reject the null. So I have sufficient evidence to, no, I have insufficient evidence to say that being a morning or evening person is independent of age.
I think that's right.
I have insufficient evidence to reject the idea. Yes.
Yes. Okay.
Because you're not.
Number 3.
Number 3?
Number 3.
As long as the p-value is greater than the significance level, I don't, is that
0.087.
and you're
0.05. Yeah.
And
Yeah.
You can't reject it.
Okay. Number 3.
You think it's the third one?
Yes.
But that doesn't make sense because you're failing to reject the null hypothesis.
Yes.
So the null is we're saying is true, right? We're failing to reject, so we're
Yeah,
Right.
so
The null hypothesis is that they're independent, right?
See, and the teacher told me to go back and restate whatever you say. Go back and
It was
restate
one
the
because you
alternative
don't have
hypothesis.
sufficient evidence. You have insufficient evidence for the alternative hypothesis because you're failing to reject the null hypothesis. So the null hypothesis would be true. So it would be the fourth one.
So insufficient evidence of them being not independent is one way to say it. But you don't have insufficient evidence to reject them not being independent, right? You can't have 3 negatives in there, or else you're going to turn it back into saying they're dependent. So just count the negatives and make sure that you've got the right negatives that turn out to say that they are probably independent of each other.
This is sounding awfully mathematical.
No, well, so if you fail to reject the idea,
It's number 4 because if you're failing to reject the null hypothesis, then the null hypothesis would be true.
yeah,
And the null hypothesis is being a morning or evening person is independent of age.
right.
So then the alternative, you'd reject the alternative hypothesis. So you have insufficient evidence for the alternative hypothesis.
You can say it that way, but it's not insufficient to reject the alternative. It's insufficient to support the alternative.
Yeah, so it would be the fourth one.
Okay, going back to that then.
Sweet.
I feel like that's the first thing I said.
it is.
Ah,
Oh, sorry, it's my turn. A recent book noted that only 20% of all investment managers outperformed the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. Based on the results of the sample, create a 95% confidence interval of P. Input the lower and upper bounds below, rounded to 3 decimal places. So input the lower bound, I had 0.190.
yes.
Yep.
Input the upper bound. I had 0.31.
Yep.
Suppose you had been in charge of designing the study. What sample size would need to be constructed, would be needed to construct a margin of error of 2% with 95% confidence? Use the prior estimate of P equals 0.2 for this estimate. And I had, except maybe my math was wrong, 1,537.
Nope, that's what I had.
Okay.
Alrighty. Suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use a level of significance of 0.05. Which of the following pairs of hypotheses is more appropriate for addressing this question? So let me just go back. Let's see, performs better. So we need P is greater than. So the second to last one,
Yep.
P equals 0.2 and P is greater than 0.2.
Agreed.
Yep.
What requirements must be met to ensure that p hat is normally distributed? I said NP is greater than or equal to 10, and N times the quantity of 1 minus P is greater than 10.
Agreed.
Yep.
The value of your test statistic is 1.768.
That's what I have.
Oh man, now I have something different. Okay. Hold on.
You want me to keep going, or do you want to stop, Sarah, and rework it?
What did you guys have?
1.768.
I think I put in something different. I don't think I had the test statistic there. So yeah, you're good. Go ahead.
All right. The p-value for your test is, and I have 0.961.
I got something different.
Okay.
I have 0.039.
Yeah, that's what I had.
Okay.
All right. Is there sufficient evidence to conclude that graduates from the top 10 business school programs perform better than other investment managers? Yes, I rejected the null hypothesis.
That's what I put.
Agreed.
Okay, do I actually need to read through all of this, or have you guys already read it?
But we've never read it. Could you read it to us?
Are you being serious?
No, you're fine.
Serious.
I will say, though, that this is the end of where I have made it in this review.
This question. So do you need me to read it?
I'll read it if you guys want to carry on.
Just open the file and
Open the file and do. It wants to know. I'll just read you the last part. How about that?
Okay.
To compare Pharaoh's ability to translate with similar computer translation software, Cohen took a random sample of 100 blocks of Spanish text, each of which contained 300 sentences, and used Pharaoh to translate each of these to English. The blue score was calculated for each of the 100 blocks. These scores are recorded in the data file. He wants to use this data to see his mean blue score. To see if his mean blue score differs from the mean blue score of another leading translation software, which has a population mean score of 0.295. Assuming the requirements are satisfied, construct a 95% confidence interval for Pharaoh's true mean blue score. Record your answers below.
So what am I doing? Okay.
it's from last unit where you compare the difference, where you have to subtract them and make a new column.
Okay, so this is the one.
Are you sure?
Is it view?
Because it only gives you the blue scores for one.
Is this the compute variable one?
Maybe that was the next one that we have to work on.
Yeah, I think that's the next one. This one's a t-test.
Oh yeah, that was the morning or
Just
evening.
a regular random t-test?
Yeah, so
Okay,
just
sorry.
blue scores. So
Let's
input
see.
the lower bound. I had 0.282.
Agreed.
Okay.
That's what I have too.
Okay, sorry, tell me the lower again.
0.282.
Yeah, that's what I got.
Input the upper bound. Round your answer to 3 decimal places. I have 0.293.
Yep. Okay, calculate the degrees of freedom, the test statistic, and the p-value for a test of null, the mean equals 0.295, against alternative, mean does not equal 0.295. Assume the requirements are satisfied. Input your answers in the next 3 questions. Input the degrees of freedom, and I had 99.
Yep.
Agreed.
Input the test statistic. Okay, sorry, let me go back up here and look again. Let's see, if I'm doing the test statistic on this one, what test am I doing? I have to go through, for the love. I'm blanking out. What's my formula for this one?
You can do it on SPSS.
Oh, what am I doing?
You do a t-test because you don't have sigma.
I did it, and
It's the t value.
okay, hang on a second. Analyze, compare means. Is it the independent one sample t-test?
Yeah.
Okay, there we go. There we go. Do I have a test value?
Yes. It's the null hypothesis.
Oh, which one? Okay, hang on. Sorry, let me try this one again. That one. Null hypothesis is 0.295. There we go. Let's try this again. T equals negative 2.803.
Yep.
Negative 2.803.
That's
Okay.
fine. Everybody else good?
Yep.
Input the p-value. Round your answer to 3 decimal places. I had 0.006.
Agreed.
Yep.
Based on the results of this test, what would you conclude? Use a level of significance of 0.05. And we have sufficient evidence to say that the true mean is different than 0.295.
That's what I had.
Sufficient or insufficient?
Sufficient.
So the last one?
The first one.
No, first one. Sorry. Okay.
Okay. Use the following information to answer the next 6 questions. A study was done to test the notion that people are taller when they first wake up in the morning than in the evening right before they go to bed. To test this theory, the heights of children in a boarding school in India were measured. Values were recorded in millimeters for each child in the morning and again in the evening. The data is recorded in AM/PM heights. You want to determine if the children are taller in the morning than the evening. Define the difference as AM heights minus PM height. Construct a 95% confidence interval for the true mean difference of heights and conduct a hypothesis test at a level of significance of 0.05 to determine if the children are taller in the morning than the evening. Input your answers below. Input the lower bound of your confidence interval, and I have 8.728.
Yep.
Agreed.
All right. Did you do the paired samples test on this one?
No, so I subtracted them and made a new column and then did just a t-test on their differences.
Like a one sample t-test?
But no. I think you can do the paired samples t-test and it still works. I think I did that once.
see. Okay, so my T on this one when I did the paired samples is 22.446.
That's what I have 2 for the T.
Yeah.
Yeah, I have that too for that question.
Okay, I just want to make sure that I'm.
But go back up, Mary, to the upper bound
Okay.
was your question, or we can swap and Sarah can take the upper
Okay.
bound.
10.455.
Agreed.
Yeah.
And then the test statistic was 22.446, as Mary said.
Agreed. Input the degrees of freedom for this test. I have 40.
Yep.
Yep. Okay, input the p-value for this test.
Hang on a second, guys. I got my numbers mixed up here real quick.
Okay.
Sorry.
It's okay.
Sorry, I accidentally put the upper bound and the lower bound, and then test statistic and the upper, and
Yeah, I did that earlier.
yeah, having fun today. All right. Great. Test statistic. What do we say the 22 point what?
446.
6 degrees of freedom is 40. Okay. All right, I'm ready.
Okay. Input the p-value for this test, and I had just 0.
Me too.
Agreed.
Yeah.
Did you put 0.0 or did you just put 0?
0.
All right. Based on your results of this test, is there enough evidence to suggest that your children are taller in the morning than the evening? I put no. Failed to reject the null.
I have yes because we rejected the null.
Wait,
That's what I have.
where is? Ooh, hold on. I'm missing a decimal. Sorry.
Your p-value is 0.
So your p-value is 0, so you reject the null?
Uh-huh.
Yeah.
Oh, good night alive. Seriously, this class makes me crazy. Okay. I'm going to be bald by the time this class is done. Oh.
All right, did somebody submit?
I did. We got 100.
All right,
Yeah.
I gotta go back and do the very beginning.
It's all because of Russell's help.
I need to be
Russell.
weekly more often.
Which beginning answers do you need, Mary?
Let's see. I think I just missed 2.
So on 2, we put chi-squared.
All right, chi-squared. There we go.
Chi-squared.
And then I think, yeah, and then I had 3. Okay.
Okay.
All right.
Awesome.
All right. Well, good luck on the exam.
Yeah. We got to tell
Mary,
me
we
what we
talked about before you got here.
Yeah.
That next Tuesday is the 4th of July. So are you good to meet on Monday evening instead at the same time?
Tuesday. Next Tuesday. You mean you don't want to miss fireworks to do this?
Well, Russell's doing sparklers, and he really doesn't want to miss that.
Oh,
Come on.
yeah, that's
You guys
important,
know
Russell.
you want to write your name with sparklers in the dark? Come on.
You must have a daughter, Russell.
I do. I have 2 of them.
That would explain a lot. Okay, so yes, I'm good on Monday. You don't have anything happening on Monday? No? Okay, so yeah, we're good.
Okay.
And
Perfect.
is it me calling?
Sure.
Yeah.
Yes. Okay.
We also talked a lot about the turning in the submit the data document or whatever.
Mm-hmm.
And we're pretty sure that we all have to submit that. So Sarah's going to finalize it, and I guess we submit it 4 times.
Why would we all submit that?
Because it says that in the instructions.
Well, let me read you what it says. No, I'm just kidding. They gave me a hard time earlier, Marianne. Don't worry, we've already been over it.
Okay. Well, let's see. Okay, that works for me.
We're not really sure about it, but
Oh, wow.
no, we're sure about it. We're going with it, even though we're pretty sure it's dumb.
Oh, yeah, I agree with that. Hey, turn off the recording.
What she meant, but we're going with it anyways.
All right, so we'll see you
Okay.
Monday.
Okay.
Sounds
Yeah.
good.
All right, thanks, everybody.
All
All right.
right.
Bye, guys.
Bye.
Bye.